So here's our first trick to move a line closer to a point that we're going to use in linear regression. It's called the absolute trick, and it works like this. We start with a point and a line, and the idea is that the point wants the line to come closer to it. So let's put some numbers here. The point has coordinates p comma q, where p is the horizontal coordinate and q is the vertical coordinate. And the line has equation y equals w1x plus w2. In here, w1 is the slope and w2 is the y-intercept. So an easy way to move the line closer to the point PQ is to just add 1 to the y-intercept, and then there it is, the line moves up. And now let's add something to the slope too to make the line rotate in the direction of the point. This is going to look a little strange, but it's going to make sense very soon. So this distance over here is p, because it's the horizontal distance from the y-axis to the point. So let's just add that. Let's add p to the slope, and now our new slope is w1 plus p, and that rotates the line in this direction. Now our new equation is y equals w1 plus p times x plus w2 plus 1. And that's pretty much what the absolute trick is about. Notice some subtleties though. Notice that we moved the line a little too much and we actually went over the point and kept going. We don't want this. In general, in machine learning, we never want to take big steps like this. Instead, what we want to do is take tiny steps. So in order to take a tiny step, we'll just do the exact same thing we did, except we multiply everything by a small number. So let's take a small number called the learning rate, let's say alpha, and instead of adding 1 to the y-intercept and p to the slope, we will add alpha times 1 to the y-intercept and alpha times p to the slope. Now the line moves up by a little bit and rotates a little bit, so we don't have that risk of going too far. And our new equation is going to be w1 plus p times alpha times x plus w2 plus alpha. So our new slope is w1 plus p times alpha, and our new y-intercept is w2 plus alpha. So we're doing better, but there's still a little subtlety. What happens if the point is not on top of the line, but underneath the line? Well, same thing, except now instead of adding, we just subtract to get our new equation. w1 minus p times alpha times x plus w2 minus alpha. The reason is, if we subtract alpha to the y-intercept, the line moves down instead of up, and if we subtract p times alpha to the slope, the line rotates in this direction instead. Something even more interesting is this, and that would explain the reason p is there. If the point is not on the right of the y-axis but on the left of it, then we still add 1 to the y-intercept because we need the line to move up. But the fact that now we're adding p to the slope and p is now a negative number means that our line now rotates in this direction. So that's a reason for p to be there. Another reason for p to be there is this. Check this out. If this distance is small, then p is small, so we're adding a small number to the slope. Now if the distance is large, then p is large, so we're adding a large number to the slope. And it makes sense that if the point is really close to the y-axis, we want to increase the slope by a little bit, whereas if it's far, we want to move it by a lot more. So let's do an example to make this more clear. Let's say we have the point 5, 15 and the line y equals 2x plus 3. So this means the distance from the point to the y-axis is 5. Now let's say our learning rate is 0.1. So we're adding 0.1 times 1 to the y-intercept, and that moves the line up by a little bit. Also, we're taking the 5, multiplying it by 0.1 and adding that to the slope, which makes the line move in this direction. This means our new equation is y equals 2.5 x plus 3.1. Now check out what happens if the point is on the left. We're still adding 0.1 to the y-intercept to move the line up, but now to the slope, we're going to add the product of 0.1 and minus 5. That's minus 0.5. This means our new equation is going to be 1.5x plus 3.1. As you can see, the slope moved in a different direction, which made it go closer to the point. So that's it. That's the absolute trick, and we're going to use it extensively in linear regression.